My name is Ryan Ashton. This is my Lab 2 report and answer sheet. First is very simple, understanding how the multiplexer works, using the select to choose either A or B as the output for Y, and then placing that into a 4-bit multiplexer. Basically, again, using the select function to choose whatever your 4-bit value for A or B is. In this case, when it's 0, your A is going to pass through as 4. And if we were to select, or I guess activate the select, then your B value would come through as shown in our wave. And then here's just some of those tests for all zeros. When your select is 0, input A will come through. When your select is 1, input B will be your output, and some other simple tests. Here's with the digits, um, the not and negate circuit. I think one interesting thing was trying to make these switch places. It wasn't until later that I found out that you can go into the settings and edit this. So for what I had to just move the wires around. But then I later found out here that you can just rearrange the order of your inputs and outputs, which was very helpful to learn. But understanding how this would invert and make negative, or in other words, the two's complement of a digit was very helpful. For the AND add circuit, which basically says whether a value is going to add together or pass, and add will just add these two functions together. For example, A and B are 3 and 2, added together will be 5, and then you have your 4-bit adder to calculate kind of carry out, overflow, and then you can also put in a carry in here, and then pass will basically just say whatever your A value is going to come through no matter what else is present. All that put into our ALU circuit finally. After some messing around, that was kind of the biggest thing with all of these larger circuits, was messing around to figure out how exactly they all worked. But understanding how the pass, invert, and arithmetic worked around, against, or with each other to produce all of these different functions. I think one of the hardest ones to understand at first was that when nothing was activated, that this simply acted as an AND gate for each individual bit. Um, various tests, I guess I did various tests to kind of show these, and despite my best efforts, I was unable to get any of the waves to work. Um, so I was struggling with that, but I do have, after calculating them out, the expected inputs and outputs depending on which was activated. Basically, how your AND function will work, how the pass through will basically pass any A value through to the end no matter what's going on. Um, the AND function with the inverter will basically take a bar and B and output however that works in your different cases. Pass through to A bar is just the pass with your inverter. And arithmetic sum A plus B is very simple. It just takes the non-complemented A and B, and then you can add a carry in to change your value as well. The two's complement version adds the inverter to the arithmetic to have positive and negative numbers that will show an expected input and I guess an expected output, and it doesn't show it on here, but it will also show your carry out and overflow if applicable. And then finally, the pass through to the two's complement of A. If you have your arithmetic inverter and two's comp or and your pass, then it will show whatever the two's complement of your A input is, regardless of carry-in. And that is my Lab 2 report.